right, so in solving a problem like this, where the force is at an angle, and there's a lot of examples of forces at an angle instead of forces horizontal. If I'm mowing the lawn, the handle is probably not horizontal to the ground, but the lawnmower is going to move horizontally. If I'm pulling a wagon, I'm going to hold a wagon at an angle that's going to be different from the direction the wagon moves. And if I'm pulling a sled by a rope, the same thing. So in this problem, we're going to have a level surface, and we have a block on the level surface. So I'm going to put that there. And then it says that the force that's applied to the block is applied at an angle of 34 degrees above the horizontal. Now, when you make an angle of 34 degrees above the horizontal, make it look like 34 degrees. Like, don't make it look like 60 degrees, because a lot of times I use the picture to check my facts. So when I make the applied force, now if I went in that direction, that would be probably about 45 degrees. If I went in that direction, it would be like 60. I want 34, so I'm going to make it so it looks something like that. So that is my applied force, and that amount was given to me in the problem as 63.5 newtons. So I'm going to write FA equals 63.5 newtons. And it was given an angle of 34 degrees. Well, what I want to do is I want all my forces to either be horizontal or vertical. So this force that I just put on my picture, I want to replace it. I want to replace it with how much of it is in the x direction, the horizontal direction, and how much of it is in the vertical direction. So I'm going to make a triangle out of this, where this is the hypotenuse of that triangle. So I am going to go over, all the way over, until I'm right below the end of that arrow. All right? Right below the end of that arrow. It's like if you were doing Etch-a-Sketch, right? You only have the two knobs. If I want to get from the lower left corner, if I want to get from the lower left corner to the upper right corner, I have to go to the right and up, or I have to go up and to the right to get there, because the knobs only make it go up, down, or left or right. So, or if you're playing that game where the crane picks up the prize, and you want the prize that's in a certain location, you go far enough in one direction so that when you go in the other, you'll end up at the prize. So in this example, I'm going in the horizontal direction, and then I'm going to complete the triangle by starting here and going straight up. And that is the vertical component of my applied force. So I want these things to be labeled. So this is going to be the x component of the applied force. And this is the y component. Oops, I'll use a different color. This is the y component of the applied force. And between, what's the angle between the two components? 90. So I'm going to go up and over. So I know that's a 90-degree angle. Now, in addition to the applied force in the x, if you look in the problem, it says that there's also a coefficient of friction. Well, if there's a coefficient of friction, then there's going to be friction. So I'm going to have a friction arrow. Friction always opposes motion. So I'm going to have friction in that direction. I'm going to make this arrow smaller than the FAX. So I'm making this arrow smaller than that one, because I'm going to assume that they're asking us for the acceleration of the block, so I'm going to assume that that's going to be enough to give us an acceleration of the block. And so now in the vertical direction, the y direction, I actually have three forces in the vertical direction. I'm going to make the weight, so the weight is going to be in this direction, and watch how long I make it. I'm going to make it so that this arrow that I just drew is longer than that arrow, because I still have another arrow up that I have to put here, the normal force. So this is going to be my weight, which I'll label it. And the normal force is going to be a smaller arrow. So that, what I just drew, that's my normal force. And what that means is if I take this arrow and put it on the end of that, so I'm going to move if I put this on the end of that, the length of that vector should be the length of the weight, because all of my vectors that are vertical should balance out, because if this thing moves at all, it's only going to move in the x direction. It's not going to move vertically, so all the forces have to balance out. And notice that in the problems that we did prior to today, the normal force and the weight were always equal to each other. Well, not anymore, because now I have another force in the y direction, so they're not going to be equal anymore. So there's my picture. Any questions with the, well, let's put everything on here, because not just the diagram, but you're putting all the facts to this problem on here. So I can see that the coefficient of friction is given above as 0.23. I can see that the angle right here I should probably have on the picture, that's 34 degrees. They're also telling me that the weight is 50 newtons. So this right here is 50 newtons. And the unknown in the problem is the acceleration. So acceleration is what we're looking for. So that's a complete picture now. That's a complete picture. It now has everything that we need to solve this. So once we have the picture, now I need my descriptive equations. I'm going to put my descriptive equations right under the picture here so that I have all this room over here to solve things. So my descriptive equations, who can tell me if I sum up my forces in the x direction? Looking at my picture, what will my descriptive equation be in the x direction? So I did it in red, and the arrows on the picture that are in the x direction are in red. So how would I write that equation? What would it be? Yes. Equals? Close. I thought you were going to get it. FAX minus friction equals, that's the F in the formula, F equals MA. So this equals MA. Anytime you write a descriptive equation, this is F. So F equals MA. Your descriptive equation is writing Newton's second law. So that's the first equation. And then when we sum up the forces in the y direction, who can tell me what that equation will be? Yes.
Is it F is still Fn minus W equals 0?
No, because you now have this force also, so don't forget that one. So don't forget this one. So you've got two arrows up and one arrow down. Up is positive, so I have to include both of these in my descriptive equation. So what would that be? Yep. Yeah, I'm going to put it in this order, though, just so that I have my components first. But you're right, FAY plus FN. What's the rest? Minus W equals 0. And again, they still equal MA. Like, these three together are the F in the formula F equals MA. But there is no A in the vertical direction. That's why we can write it as 0. But F equals MA. These two combined are the force in Newton's second law. So there are your descriptive equations. Any questions with that? Okay, now we're just going to solve things like we have in the past in the order that they can be solved. We have to first solve for the two components. And this is where you have to use right triangle trig. We have FAX, if this is my triangle, and that's the angle that I'm using as my reference angle, then what side of the triangle is that? That's the adjacent. And we know the hypotenuse. We're looking for the adjacent. What trig function involves the adjacent and the hypotenuse? Cosine. So solving for FAX, it's going to equal the FA the hypotenuse times the cosine of the angle. That's how we're going to get FAX. We're just going to take the hypotenuse and multiply it by the cosine of the angle. Now, don't write down what I'm going to put down next. I'm just going to do it to explain where that comes from, and then I'm going to erase it. But remember, the cosine of theta is equal to the adjacent over the hypotenuse. So I want to get what the adjacent is. The adjacent in my problem is this. That's the adjacent. So I'm going to move this to the other side so that I have the adjacent equals the hypotenuse times the cosine of theta. There's the adjacent equals the hypotenuse times the cosine of theta. So it will always be hypotenuse times either sine or cosine. You've got a 50-50 chance of being right, but another thing that you can use to help you check your work is the picture itself. Because look at my picture. This arrow is bigger than that arrow. If I mix up cosine and sine, let's say that should have been sine, then this will not be bigger than that. So I know that because the first two things I'm going to solve for are FAX and FAY. This one better be bigger than that one. If it is, then I probably picked the right one between sine and cosine. So we're going to put in here the full applied force, 63.5 newtons, times the cosine of 34 degrees. Okay, that's how we're going to get FAX. And what does that work out to be? I may have to stop this podcast early simply because I'm going to run out of, maybe I'll stop it and start it to do like part A, part B. What do you get for this? You want to work it out with the calculator? What do you have? What's after the 6? Okay, so 52 points, because I thought in the other class it was 52.7. Okay, 52.6 newtons. That's going to be your applied force in the x direction. I'm going to stop the podcast here, and then I'm going to pick it up. So let's